Thank you. Hello, everyone. This is Louis. I lead the developer relation team with Agipulse. In today's session, we are going to speak about the dataset best practice, how you can go from a prototype to a production dataset. Are you ready to go? So let's get started. In any AGI project, you have more or less the same architecture diagram. In today's session, we are going to focus on the key part around the data. So how to collect data, how to curate, how to prepare, how to label your data, and then how to keep on collecting data from the device that has your model running. So we are going to go over the importance of the data sets. We are going to try to ask the right question to define your project, what tools will be available to you for quick prototyping, how you can label your data, and how you can make sure that your labels perform well or are valid, how you can leverage synthetic data to improve the robustness of your model, and then how you can scale to production, how you can have a rock-solid data set that is ready to train robust models. And finally, we are going to see some common biases in datasets, so you can make sure to avoid those. And that's, in my opinion, super important. So datasets are the foundation of any AI models. High quality data leads to accurate and reliable results. On the other hand, we used to say in machine learning, garbage in, garbage out. I'm pretty sure you understand that, but if your data is poorly labeled or is not large enough, your models will perform terribly. Now, what is a good data set? Well, there is no good answer in that, but the first question you need to ask yourself is, what is the problem you are trying to solve? Is my use case scoped and constrained? In that case, it's probably easier. Or on the contrary, if it's very diverse. Let's take the example of a fixed camera that analyzes a conveyor belt. By the way, this project is a project that keeps on giving. We've been using these cubes on a conveyor belt example for many things. Here, as you can see, the environment is relatively stable. The camera is fixed. Maybe the lighting condition will change a bit. But on the overall, I consider this as a stable environment. Same applies for something that could be considered a bit more complex. Let's get the example of this soccer game field or soccer game analysis. You always have the field. You'll have some players. Obviously, some conditions will change. Could be the lighting, could be the player's outfits. But overall, it's still a scoped use case. You have a fixed camera. Let's take another example. Here in this case, it's a wake word detection model for your car. In that case, the environment is much more dynamic. So you might have some background noise, some kids crying in the car, some surrounding noise, some different accents, different ages of the speakers. Here in that case, the complexity is higher, and it will impact, obviously, the performance of the model. So in that case, a good data set should include a wide variety of data samples. And to try to answer that question, so what is a good data set? A good data set is a representative set of the real world scenario. So your model might encounter different scenarios, and it needs to represent all the variation possible. They may include environmental conditions, such as we've mentioned that before, lighting, noise, could be weather. Especially when dealing with people, it should include demographic factors, such as different age, different genders, different accents, but could also be different skin colors, etc. And then also all the edge cases, all the unusual or rare situations that might occur, it needs to be collected. And you could also put some more weights on those if they are underrepresented in your dataset. Now, what tools do we have and what questions you need to ask yourself to create a good prototype dataset? The question I always have is, how much data do I need? So again, there is no good answer in that, but while larger data sets can lead to better performances, the size should always be appropriate to the problem. Sometimes, and actually more often, like a smaller but well-curated data set can be much more effective than a large and poorly managed one. I'll still try to give you some numbers and some tips. So how much data? Let's say 2 iterations of your model. Try to train a first model with, let's say, so those numbers are completely made up. But let's take, for example, 50 data samples. Train the first version of your model. You might arrive to something around, like, let's say, 55% of accuracy. Now try to collect some more data. Say 200, retrain the model with the same parameters, you might arrive to something around 60, 65. Now, interpolate the results, and you will have a rough idea on how many data samples you will need to attain like the desired accuracy. Or accuracy could be any performance metric, could be F1 score, could be something else. In reality, the trend of the line looks more like that. So the more data you collect at the end, like, then you'll probably never reach 100% anyway. So track your experiments. This is already a tip that I can give you. You will have some information. If you see some decrease, it probably means you have an issue in your data sets, or it could be something else, but I'll let you figure it out. But yeah, the curve should look like that. Now, since the start of EdgeImpulse, we have been developing some tools to help you connect your data sets. I think my favorite way to collect some data is to use your smartphone. This is super convenient. You take your smartphone, you flash the QR code, and you can go in the world and start collecting data, especially if it concerns like the image, audio, and vibration modalities. This is super convenient. I've been on field trips to collect some data in factories. Honestly, this is really an easy way to go. All the data will be automatically added to your EdgeImpulse project. So to arrive to that screen, create a project on EdgeImpulse, go to Data Acquisition, and click on the button Collect Data. This model will appear, and you can get started. If you want to work with different sensors, for each of the official development boards that we support, we provide a firmware or binary that you can use to flash your device. It will connect that device to your EdgeImpulse project, and you can start sampling data from a real some real hardware. It could have different sensors, such as temperature, time of flight sensors, radar, some other things that we have. You could use some sensor fusion, so different modalities or different sensors collected at the same time. This is very handy. Now, many of our users already have data. You might also want to try a data set that you found online to see if it could be suited to your projects. In that case, we provide some options to upload your data set, and we support like a wide variety of files types, such as CBORD, JSON, CSV, Parquet, audio, images, videos, etc. And you can also parse your data if you have a data set that is in a format that we don't support, into a file called info.label. And in that case, we will extract the labels for each of your data sets. To do that, you can use the Studio Uploader to upload your data, the CLI Uploader, the CSV Wizard, the Ingestion API. I use this quite a lot. For example, if I've got a Raspberry Pi in the field and I want to keep on collecting data, it's super easy to just do a web request, an API request to send your data, and they will appear to your studio, to your projects. If you have your data living in cloud storage, such as AWS S3, Amazon, Microsoft Azure, or Google GCP, you can also directly import or link your buckets to your project, so you can easily import your data. And finally, we have the Python SDK that you can use mostly if you. I use that if I have a Jupyter notebooks where I need to parse some data, I can easily with one command, one line, send some data. Edge Impulse also supports a wide variety of different format and datasets annotation formats. For example, on object detection could be Pascal VOC, YOLO-TXT, CocoJSON. We have our own Edge Impulse object detection formats and OpenImage CSV. That's good. That's how you can upload data. But what if you don't have much data and you want to create synthetic data? So you might want to create synthetic data for several reasons. The cost efficiency. So creating synthetic data can be more cost effective and efficient than collecting real world data from large volume real projects, especially in resource constrained environments. You might want to use synthetic data for data augmentation. So synthetic data allow you to augment your real world data with some variation, which can improve your model robustness and performances. You might want to add some diversity in your existing data sets. So synthetic data in that case enables the inclusion of uncommon or rare scenarios. And again, it will enrich your training data with a wider range of potential inputs. And then privacy and security. So when dealing with sensitive data, for example, synthetic data can provide a way to train models without exposing the real information. In that case, enhancing your privacy and security. So if you want to know more about synthetic data, I invite you to attend the AI labeling and synthetic data session that will be run by my colleague Ashvin. You will have much more details on all the synthetic data blocks that we provide. Similarly, we have tools for using AI labeling, so using LLM or VLM to help you understand your data. That can either to put a label on your data samples, also some metadata. You can use it to validate. My colleague Ashvin will also cover that, so I'm not going to enter too much into details, but this is an example of what you can expect in the studio using GPT-4o. So this is a block that can help you label your image. In that case, it's a cloud classification. So what kind of a cloud technology it is. I'm definitely not familiar with all the clouds type, but this, for example, you can leverage LLM knowledge to help you do that. Now, one of my tips would be to use your own model. So train a first iteration of your model. And then I put together a GitHub repo. So github.com/edgeimpulse/example active learning Linux Python SDK. This will help you to select the threshold on the prediction score. So you can only upload to your projects data samples that are like, let's say, in between two thresholds. I think in that case, I set, so that's a keyword spotting model. So if I want to say yes, no, okay, go, etc., I only want to collect the data that are between 0.6 and 0.8% of accuracy. So this will improve my model robustness by by adding models that were originally not uncertain, but let's say not 100% confident or not 90% and above confident. Those kind of tips or techniques can help you improve your model robustness. And then another tip is start small and iterate quickly. I've got here an example of a vibration analysis on a piece of machinery where the very first model just tried to classify two things: whether the model is in idle mode or running in its nominal mode. So idle, it doesn't do much. Nominal, it's just a machine running continuously. Train that model, and over time, collect some more data. When you, so here I did the anomaly detection. So keep aside all the anomalies that you detect. At some point, once you have enough data, you might start to distinguish some clusters. And whether you bring some technician or engineering knowledge, you will be able to put a label on those. So here, for example, on one that have a heavy load or a seal failure or something else. This Data Explorer tool is pretty handy. It lets you just drag and drop kind of a box and put a label on all those data samples. That's pretty easy, and this is how you can scale your prototype dataset pretty quickly. Now, speaking about scaling, how can you scale your model to clinician? So since the start of EdgeImpulse, I think our first customers that we signed was because of all our data curation and data pipelines tool that we provide in our organization sections. Let me give you an example of a health wearable machine learning pipeline. So to create those kind of health wearables, could be a watch, could be a ring, could be a headset, could be another thing that you patch on your body. But those involve clinical studies. Clinical studies are extremely expensive. You need researchers, data scientists, you need patients, you need like the devices themselves that you want to, or at least sensors that you want to use to train your model. And most of the time you need a health or medical clinical device or medical reference device that will correlate your results, and you will set the labels from this medical device to the objective of training a model that mimics the medical device on a wearable. So it's super important to catch errors early. In that case, we've been providing tools, checks to help you do that. I'm not going to enter too much into details. Those are organization features. I gave a webinar, I think a few months ago, maybe last year, around all the advanced features of EdgeImpulse. So how can you add some checks, correlate some label with the medical devices, resync the time, do all things. But getting gold standard labels is super hard, and if you catch errors early, this will save you a lot of money. I've got another example. This is around the industrial machine learning pipeline. It's basically the same. It just does not involve clinical studies, but collecting data on real machinery and in factories could be hard, could be expensive. So we have expertise in those industrial machine learning pipelines, especially in the data collection. Feel free to come to us if you have any question. Now, let's jump into how you can identify your bias in your dataset, the biases. I think this is one of the most important things to make sure your model will either be robust or diverse enough to cover a wide variety of use cases. Use metadata. So metadata are fundamentals. By analyzing the metadata, you can ensure your data is diverse and is representative across various scenarios, all the dimension. For example, like gender diversity, age diversity, location, accent, even the device used for the data collection. For me, it's important. You might see some difference at some point in your real world devices. You might have a microphone from one brand or from a brand, another one from another. If you want your model to work across a wide variety of sensor type, you need to collect data from those sensors. So if you make sure you collect and you add as much as metadata, you can analyze those, see the representation, see the diversity. It will give you a lot of context, and you will be able to analyze that to understand why it's not working and understand why it's working well. Something else I wanted to speak about in this session is I'm not sure if you're familiar with GradCam. So I actually discovered that probably 2 or 3 years ago when I was speaking with one of our machine learning engineer at EdgeImpulse, one of our in our research and development team, and he told me, one of the biggest bias in the most common use case is on the cat versus dog classifier. it could actually work as an indoor versus outdoor classifier. I said, how comes? And he told me, like, if you analyze the data on data that were used to train the model, most of the data of the dogs were taken outdoor, and most of the data on the cats were taken indoor. So I said, okay, how can I validate that? And I was doing some research. I came across the GradCam techniques, which let you basically visualize the convolutional neural network, so where the model focuses on to take a decision. And here it's an example of my test data set. So I had two representative samples. One cat that has been misclassified. So one cat has been classified as a dog, but effectively it's outside. So here the model, I'm not sure if you see like on the reddish area, it mostly focuses on the grass, and on the dog, it mostly focuses on kind of the window, the sofa, and everything that relates to the indoor environment. So this is actually, so I wrote an article about it. If you want to have a look, feel free, or just type GradCam EdgePulse. I'm pretty sure you will find it easily on your search engine. Another common bias is, so that was another example. Here the model focuses on the annotation of the image rather than the lung itself. So this was for a pneumonia detector. When I was speaking to that researcher as well, he told me, like, in tumor detection, most of the time, when there is a tumor, usually you have a rule to see the size of the tumor. So when a model gets trained with those images, the model will actually try to focus on finding a rule rather than focusing on the cell or the tumor itself. So this is another bias in your dataset. So make sure your datasets are not biased. I hope I answered some of your interrogation. This is it for me today. I would like to thank you a lot. This was Louis Moreau from EdgePulse, and I will stay here to answer your question in a Q&A session. Thanks a lot. That was Louis.